Okay, so in this video I'm going to use law sines and law cosines to solve a couple of word problems that produce triangles. So here's the first one. It's a boat. It's kind of a cool looking boat. So suppose a boat leaves port, travels 10 miles. That's this part right here. And then turns 20 degrees, so notice it shows 20 degrees turning from its direction. It was going in this dotted line direction, and it turned 20 degrees to the west, looks like. Is that the west? Yeah, to the west, if this is north. And then it goes another 8 miles. How far from port is the boat? So what we really want to know is that question right there. So you can see that what we're going to do here is try to solve the triangle, although we don't have to find all the missing pieces. We only have to find the one that it indicated. So first thing we checked and ask ourselves, do we have an angle inside opposite it? Because that would give us that allows us to use law sines. And we don't, because we know that this is 8 and we don't know what that angle is. We know this is 10, we don't know what that angle is. And we can find this angle, but we don't know what that side is. So we cannot use law of sines, we have to use law of cosines. So let's call this C. So we're looking for C squared. That means we need A squared, which would be 64, plus B squared, which would be 100, minus 2 times 80, which would be 160. Whoops. 160. Cosine. And now we need to know what that angle is there. Well, you notice this is a straight line here, so that means this angle would be 180 minus 20, so that would be 160 degrees. Okay, so now we just got to find out what C is, or find out what the right side is and square root it. So that would be 164 minus 160 times cosine of 160. A lot of 160s in here. Remember, you cannot do 164 minus 60 because 160 is multiplied by cosine. You got to multiply first. Okay, so I'm going to go 164 times cosine of 160. I think I'm in degree mode. And I get C squared is equal to 14.35. So I square root that. And I get C is equal to 17.7. So we would say the boat is 17.7 miles from home. Okay, so there's one example. Let me find a couple more here. So here's a couple more problems. The surveyor has taken the measurements shown in the figure. Find the distance across the lake. Round answers to the nearest tenth. So we need to know how long that lake is. And we don't want to wade into the water or swim through the water to find out how long it is. So we're going to do some surveying, or we get someone else to do some surveying, and we can find out. So in this case, we notice once again, we have two sides and an angle. The angle is between the two sides. So that means we cannot use law sines because we don't know that side and we don't know those two angles. We have to use law cosines again. So we'll call this, I don't know, just to change things up, we'll call it A for now. So that means A squared has to be equal to 800 squared plus 900 squared minus 2 times 800 times 900 times cosine of 70 degrees. Notice that 70 degrees is opposite my A. Okay, so I'm going to throw all that in my calculator. Let's see, 800 squared plus 900 squared minus 2 times 800 times 900 times cosine of 70 degrees. And I get A squared is approximately equal to 957.490.99, so I round off to 491. And then we got to take square root of that. Square root, second answer, and we get A is approximately equal to 978.5 means that the lake is 978.5 feet long. Okay. Second question says a satellite circulates the distance and angle. What, a satellite? Calculates the distance and angle shown in figure, not to scale. Find the distance between the two cities. Round answers to the nearest tenth. So the satellite is 350 kilometers from this city and 370 kilometers from that city. So we should be able to solve this triangle to find that distance. We'll call it D, just for fun. And again, we can't use law signs here, so this would be D squared is equal to 370. I might have enough room here. I'm going to make a little more room. We'll go D squared has to be equal to 370 squared plus 350. I'll put degrees instead of squared. Squared minus 2 times 370 times 350 times cosine of 2.1 degrees. So once again, grab the calculator. We go 370 squared plus 350 squared minus 2 times 370 times 350 times cosine of 2.1. And I get 573.9. And if we square root that, we get 23. So D is approximately equal to 23.95, so we'll round it off to 24. Approximately equal to 24 miles. So the cities are 24 miles apart. Notice that each time on these word problems I'm doing the math and then I'm taking the time to write the answer out as kind of as a sentence, and that's expected standard procedure when you're doing word problems that you need to be able to answer a problem with words. Okay, so let me find maybe one more problem here. So here's a problem involving a blimp. Represents the height of a blimp flying over a football stadium. Find the height of the blimp if the angle, so we want to find the height of the blimp, which would be a perpendicular distance. If the angle elevation of the southern end zone, point A, is 70 degrees, so that's the angle elevation. The angle elevation from the northern end zone is point B, 62 degrees. The distance between the viewing points of the two end zones is 145 yards. Okay. So if we need to know this height, what my strategy is, I'm going to find this side first and then use either law signs or just regular right triangle trig to find the height. Okay, but we got to find A first. You can't find the height without finding A first. Or you could find B if you wanted to, it doesn't matter. Okay, so I'm going to find A by saying, so we'll ignore that line in the middle for a minute. We're going to say, okay, A over sine of 70 has to be equal to, now we need 145 because that's the one side I know, and we need to know this angle right here because that's the angle opposite 145. Well, if we take 180 minus 70 minus 62, we get 48 degrees. So this would be sine of 48 degrees. So now if we just solve for A, we get 145 times sine of 70 divided by sine of 48. And we get A is equal to, approximately is, 183.35. Okay? So now that we have A is equal to 183.5, now we can find H. And so we're going to ignore this part of the triangle over here and look at just this new right triangle. So now we could use right triangle trig, or you could use law signs again. Law sign still works even though it's a right triangle. But we know this is in 9 degrees because we picked it to be a height, so that's 9 degrees. So now what we're going to do is we're going to say A, well A is 183, sorry. we're going to say 183.35 over sine of 90 is equal to h over sine of 62 degrees. And like I said, you could have just done, just use sine because this is we know the adjacent, or we know the hypotenuse and we want to find the opposite. So you could just use sine. In that case, you'd say sine of 62 is equal to opposite h over hypotenuse, which would be 183.35. So either one of these you solve, you should get the same answer. Of course, sine of 90 degrees we all know is 1, so you can see that you're going to get the same thing. You're just multiplying 183.35 times sine of 62 degrees. So we go times sine of 62, and we get, either way, we get h is equal to 161.9. So the height of blimp is 161.9, what is it, meters, feet, yards. Of course it's yards, we're talking about a football game. Okay, so I think that's enough examples. So again, a lot of these examples I give you, the triangles already drawn, but you sometimes will have to draw the triangle yourself. But once you get the triangle, put the values in the place that you know, and then figure out whether you can use law of sines or law of cosines or even just right triangle trig.